Hi, today I'm going to explain you how to implement IPsec tunnel within the Palo Alto platform. So here our network architecture is we are having a branch office, and the branch office people needs to communicate head office through this internet in a secure manner, so and also in a low cost manner, because when it comes to uh, other connections like MPLS and also IPVPN, those connections are available. So in that case also we can communicate secure manner, but the problem is actually the first problem is actually those connections are pretty much slow. And also the second issue is actually we have to pay lots of money. So actually, in order to overcome those two problems, actually we can use IPsec tunnels between these two locations and through the internet. So let me get my whiteboard. Here actually, before the implementation, actually I'm planning to give you an overall idea about IPsec. Actually, please note that this is not a deep understanding or the deep explanation, but I'm going to give you some overall brief idea about this IPsec. So my first question is, what is IPsec? So actually, IPsec means, let me draw this diagram here. Let's say I have my head office here. I'm sorry, one moment. Let me get my. Okay, I got my pen tool. So here, let's say we have this. Let's say we have our head office here. Let's say this is our head office firewall, and this is head office. And also here, behind the head office firewall, we have a network. So we have servers behind this firewall, and also endpoints and all, like PCs and all. And here we have a branch office. This is a remote location, and this is our branch office firewall. This is our Palo Alto firewall. And behind the Palo Alto firewall, in the branch office also, we have a network, and we have many users are using this network. And the in between these two locations, what we have is we have the internet. So in between these two locations, we have internet. This is internet. Okay, the actual requirement is to communicate from branch office to head office or vice versa uh, through the internet in secure manner. So actually, we have many options, like as I already mentioned, that we can have IPVPN from your service provider, also MPLS connection, so whatever the connection. But the problem is actually we have two problems with those connections. The first problem is actually those connections are pretty much slow, and the second problem is actually those connections are pretty much costly. So actually, in order to overcome these two problems, what we can use is we can use IPsec. So let me explain what is IPsec. Actually, IPsec is a tunnel connection. It's a the virtual connection actually. So we are connecting these two locations through the internet using this IPsec tunnel. So actually, the basic idea is it's a pretty much a virtual connection through the internet, and the requirement to have this connection is your these two devices in these two locations, like head office firewall and the branch office firewall should support IPsec. It's the first requirement. The second requirement is actually these two locations must have proper internet connection. Actually, if you do have internet connection, then you can build this IPsec tunnel. So those are the two requirements we have, and this connection and this connection is a this connection does not require any additional things, like anything from service provider. We do not need any service or anything from the service provider. Only thing is you need to have internet connection, and also these two devices must support IPsec protocol. So that's it. So then you need to know why IPsec. So actually we got the we talked about these two problems with the previous connections, like IPsec, or sorry, IPVPN or the MPLS. So the problem was that those connections are pretty much slow, and also those connections are pretty much costly. So, and also in the IPsec, when it comes to IPsec is actually it is you know we can have high speed connections, because if our internet connections are pretty much okay, so then we can have high speed connection. And also the second thing is actually we can have these connections I mean in a lower cost, because actually we only have to pay the internet connection fee only. So then the third thing is actually this connection is secure. This connection is secure. Actually, you using previous connections also you can have a secure connection. And also here the IPsec connection also secure, even though it is the traffic is or the information is traversing through the internet. But using IPsec protocol we can make this connection secure. So this connection is secure. So my third question is phases of IPsec. So actually when it comes to IPsec we have several phases. So actually I'll try to explain those things when I'm deploying these IPsec connections within the Palo Alto platform. As a basic thing, so I'll tell you that when it comes to IPsec we have two phases. The first phase is called phase 1, and we have phase 2. We have phase 2. So actually when it comes to phase 1 we are using something called IKE protocol. So IKE means Internet Key Exchange. So that is IKE means Internet Key Exchange protocol. And also the phase 2 is the IPsec itself. So this is IPsec. So in this case, actually, the phase 1 is just to use to the negotiate certain keys and algorithms and all for the phase 2. Actually, within the phase 1 we are not transferring any actual traffic. So let's say you want to communicate from branch office to head office. You have some kind of a database server in the head office, and people from the branch office needs to communicate to this database. So in that case, actually that actual traffic is not going to be transferred through this phase 1. Actually we are building this phase 1 in order to build phase 2, because actually we need certain keys, and certain algorithms should be exchanged between these two peers, head office peer and the branch office peer, or the head office firewall and the branch office firewall. So in order to exchange those things only we are building this phase 1. Actually phase 2 is the actual phase that we are sending actual traffic, actual, let's say you are communicating with the database, so then that traffic is passing through the phase 2. Actually you just keep that in mind, because I just want to give you some overall basic idea here. So then our fourth question is modes of IPsec. So when it comes to IPsec, we can use IPsec for two purposes. The one purpose is, let me draw it here because otherwise you won't understand. The first purpose is, let's say you have here you have a let's say a web server. Let's say this is W, that is web server, and also here let's say you have a database server. I'm putting D since it's a database server. So in that case we are, let's say we are having IPsec tunnel, but this is somewhat different than the previous diagram. Actually in previous diagram this IPsec tunnel is configured within this head office firewall, and also with the branch office firewall. So actually this connection is terminated, or connection is connected to head office firewall, and also to the branch office firewall. So in that case actually the thing is actually actual traffic is not initiated from this from this head office to the branch. I mean head office firewall to the branch office. I mean this is not initiated from the head office firewall to the branch office firewall. It is not the connection actually, because actual connection, actual traffic is which is initiated from this head office network to the branch office network. But it is going through this firewalls and the connection, IPsec connection, but actual traffic is initiated from the head office, let's say head office network to the branch office network, or otherwise from branch office network to the head office network, not from the branch office firewall to the branch office, sorry, head office firewall. But in this case actual traffic, actually the IPsec tunnel is connected to the web server and to the database server. Actually you do not have any firewall in between. So the connection is terminated from the web server to the database server. Then the actual traffic is initiating from the web server to the database server. So you see that we are having the connections between these two hosts, web server, between this web server and the database server, and also the connection is initiated from the web server to the database server. But here it's not like this, because connection is terminated or connected to the head of his firewall and to the branch of his firewall. But actual connections are initiated from one way, or for the first scenario, let's say the connection is initiated from the head of his network, and through the firewall, through the connection to the branch of his firewall, and to the final destination is the branch of his network. And also, let's say other way around, so there's a connection initiated from the branch of his network, and through the branch of his firewall, through the connection, and through the head of his firewall, and the final destination is the head of his network. So I think you know the difference between these two scenarios. So in that case, actually, if we are having this scenario, our first scenario here, database server to the web server, so in this case, actually, we are using something called transport mode. Transport mode. Transport mode. But in this scenario, this head of his firewall, branch of his firewall, and the networks behind those firewalls. So in that scenario, actually, we are using something called tunnel mode. Tunnel mode. Okay. So then, don't worry about these two terms. Actually, since I just want to give you some overall basic idea, only I'm giving this information. But when I'm configuring the actual IPsec, the tunnel, I'll try to explain certain things related to these, facts. But for the moment, I'm going to stop this explanation. So now let's go to the actual configuration. Okay, so then let's start the configuration. So let me log into the firewall. Actually, this is my PAHO means PA head office, and this is PABO means PA branch office. Actually, this is the head office firewall, and this is the branch office firewall. So actually, I have a diagram here. So actually, this is the topology. Here we have the head office client, and also this is the let me get the whiteboard here. So then I can draw. Okay. Here. Okay. So you can see this is my head office client, and this is the head office firewall. And actually, I have in order to represent the internet, actually I install actually this is router. This is a Windows machine, and actually it is acting as a router. So actually, I install this machine in between these two, head office firewall and the branch office firewall, in order to represent the internet, because actually I can take packet captures within this machine, within this this machine. So actually, the IPsec tunnel between this head office and the branch office is going to be established through this machine. Actually, we don't have to configure anything. I mean, within the machine, but actually, I use that in order to then we can have the packet captures there within this machine. We can have the packet captures. So then I can demonstrate uh, the difference between the clear text traffic and the IPsec traffic. Okay, so then this is our branch office firewall, and this is the branch office client. So actually, what I'm going to do is let me change the color. Uh, okay, so what I'm going to do is I'm going to initiate a ping request. Let's say from head office client to branch office client. So this is my ping request. So then it should go through this head office firewall and through this IPsec tunnel. But initially, I'm not going to establish IPsec tunnel. I'm going to just to ping. So then the traffic should go through this machine, or this this router as a plain text. So then I'm going to take a packet capture there. So after that, it should be received by the head of his branch of his firewall, and then it is going to be received by the branch of his client. So that should be the path. So initially, without establishing this IPsec tunnel, I'm sending a ping request. So let me remove this. Okay, so then let me go to actual topology here. uh, Let me get my virtual machines. Actually, this is my head office client, and this is my head office firewall, and this is the the router. Actually, this is a Windows machine and it is acting as a router, so I represent internet here. And one moment. Okay, so this is my branch office firewall, or the Palo Alto firewall. This is my branch office client. So what I'm going to do is I'm going to initiate a ping request here using my let me try to increase the font size. I think we can do that. Okay. uh, okay, I'm going to initiate a ping request from head office client to the branch office client, that is 192.168.200.50, the IP. So let me confirm that from here. Let me go to network connection status and support details. Yeah, it's 192.168.200.50. So let me start the ping request. Now you can see we can ping that location. uh, so let me put a continuous ping here, and let me try to take a packet capture within this internet router. So let me start Wireshark, and let me put a filter here, ip.dst. uh, okay, our filter is this 192.168.200.50. Let me filter, let me then start. And see, you can see now we have a ping request. It is starting from 192.168.100.50, and the destination is 192.168.200.50. Okay, so that's it. So then let me stop this ping request. Okay, so then let me go to the firewall, because actually now what I'm going to do is I'm going to establish the IPsec tunnel. Let me go to head office firewall. Actually, I had to go to the web interface in order to do the configuration. This is the head office firewall. And the initial thing we had to do is we had to go to network tab. And here we have to create the IK gateways. So and on your left hand side, you can see this. Let me highlight it here. So I think you can see right here. This is IK gateway. So then I had to add a gateway. Actually, this is for the the phase one. I think I explained you that phase one means we use phase one in order to you know build things required for phase two. Actually, in this demonstration, I'm talking very high level, but actually I'm planning for another demonstration. Most of the cases I'm planning for another demonstration that is totally for IPsec concepts, because actually this is totally focused on Palo to IPsec configuration. Actually, this is not Palo IPsec concepts demonstration. So okay, so then this is the IPsec gateway, IK gateway, actually the phase one gateway. So let me put a name IKGW, and then I'm using actually the IK version 2, because latest version is IK version 2. And also let me select the interface. The interface should be this interface, because this is the interface which is connected to the let me showcase this interface is this one. So let me get the pen tool. This is the interface. Okay, so then let me clean that. Okay, here let me drop select the IP 172.16.1.203. So then let me enter the PID. So that is branch office interfacing interface 172.16.2.203. And then actually in this demonstration we are using a pre-shared key in order to establish the in order to establish the phase one, because in phase one these two peers should verify each other, because actually we are using something called Diffie-Hellman key action in order to generate same key within those two IPsec IPsec hosts or the firewalls. So in that case, actually, these two peers, should identify or verify each other. So in order to do that, actually, we are using pre-shared key. Actually, we are not using pre-shared key in order to do encryption or anything, but in order to verify two peers, we are using pre-shared key here. And another demonstration, I'm showcasing how to use certificates instead of using pre-shared key. So here I'm using a very simple pre-shared key, but when it comes to a production environment, don't use simple one, because that can be a security hazard. So actually that's it. So then let me go to advanced options, and here IKE crypto profile. Actually, I forgot to show that to you. I'll show it to you. I'm using default one. Let me click OK. And actually this is the one, IKE crypto. IKE crypto means actually this is the profile that I use, because in this profile we are selecting whatever the Diffie-Hellman group that we are using, that is group 2. And authentication, for the authentication we have to use hashing algorithm. We are using SHA-1. And for encryption we have to use encryption algorithm. Here we have two things, AES and 3DES. And also we have important thing, key lifetime. So that means actually after this lifetime it is going to be renegotiated. So actually our key lifetime is 8 hours. So that is important for the security purposes, because if one key is going to be used, that can be uh, identified by some third party. So because of that we are changing the key lifetime is 8 hours. Okay, so that is our IK crypto profile. So actually we are using these algorithms and these lifetime in order to build the phase 1. Okay, so then let me click OK, because actually I'm not going to deeply explain these things because it takes more time, but I think you got the idea. The basic idea is actually we are establishing the phase 1, and I already told you that phase 1 is not for actual traffic transfer. Actually phase 1 is for just to exchange the keys and all required for the phase 2. Actually phase 2 is the actual IPsec tunnel, and that is the phase that we are actually sending the whatever the required traffic encrypting. So that is that. So then let me go to, this is IK gateway. Gateway is fine. So let me go to IPsec tunnels. Actually this is the IPsec. Actual traffic is transferring through this tunnel. So let me put the name IPsec, and also let me select the tunnel interface. Actually we can create a new tunnel interface here. Let me put 2, and here the virtual router should be default. And the security zone, actually we have previously created the security zone. Actually I'm not using it, I'm using it for this purpose, IPsec. Or you can use whatever the name I'll show you how to create it from here. So you can just click on this zone and you can put a name. Just you have to, only thing you have to do is put a name. So actually since I have that zone, I'm using it. And also that's all, because you don't have to put IPs or anything. So let me click OK. So then actually here this is the IK gateway which I created previous step, and also IPsec crypto profile. Here I'm using the default one. So let me click OK, and let me show you that profile. This is IK crypto profile. Let me open the default one. Here also we have this encryption algorithm. So let me open it again. I don't know whether I entered something. This is encryption algorithm, and also this is the authentication hashing algorithm, SHA-1. And this is a DH group, Diffie-Hellman group, that is group 2. Actually this is called PFS. Actually let me show you here. If you don't want to use that, we can put no PFS. So actually PFS means perfect forward secrecy. So that means the key, that the key is continuously changing, because this lifetime let me show you that. If you are going to use no PFS, that means you are going to use the same key. But if you are using the PFS, we are going to exchange the different keys, because the importance is, if you are going to use same key, let's say you are starting your IPsec tunnel, let's say today, let's say your IPsec tunnel is up and running, because normally IPsec tunnels are up and running 24/7, because normally we connect to two networks using IPsec tunnel. So in that case IPsec tunnel is up and running. It is not like this SSL VPN or the remote access VPN, which was I demonstrated a few videos ago. And because IPsec, since the IPsec tunnels are up and running 24/7, let's say today you are starting IPsec tunnel, are starting transferring some information. So let's say after 1 year time, sometimes some person is going to identify the key. So in that case, that person can, let's say that person is gathering all the information that you are sending through the IPsec tunnel, but the thing is actually that person cannot read that information since he does not know the key. But after 1 year's time, if he is going to identify the key, so then he can decrypt all the traffic he gathered. That's the problem. So if you are going to use PFS, so that means perfect forward secrecy means even though that person is going to identify that key, he cannot decrypt previous traffic, because actually previous traffic was encrypted using some different key. So that is called this PFS, and the key lifetime is 1 hour. Okay, I think you got the idea. But here very important thing here. So let me highlight it. Let me get my pen, and let me get the okay color is okay. This one, the IPsec protocol. Actually, this is important because when it comes to IPsec, we have two protocols. We have ESP and we have AH. So let me showcase the second protocol. We have AH. See, we have AH, we have ESP. Actually, there's a major difference between these two protocols. Actually, when it comes to ESP, actually we have this encryption. So that means we have encryption means people cannot read whatever the information that is being sent through the IPsec tunnel. ESP means encapsulated security payload, and also we have AH. AH means authentication header. So that means in authentication header, actually we have only the authentication of PS and also the data integrity. So that is the only functionality that we can we gain from the authentication header. So that's it. So then let me click OK. Okay, now let me go here, and we are done with our IPsec tunnel. So then actually we have to have a route entry within our virtual router, because actually when it comes to Palo Alto is a route based VPN. So actually in order to send traffic through this tunnel, we have to have a route entry. Okay, so then let me put that route here. Let me go to virtual router, and let me go to default virtual router static routes, and let me add the route. So actually this is our head office firewall. So let me put this IPsec. You can put whatever name, and my destination should be 192.168.200 dot, let's say 50, or let's say let's put the whole network 200.024, and the interface should be tunnel 2, I guess, because actually we use tunnel 2. And actually here we are not using any next hop IP, because only requirement is to put the traffic into the tunnel, since the Palo Alto is a route based VPN. Because when it comes to policy based VPN, we do not have to put these routes. Actually there's a policy in order to send the traffic through this encryption. Okay, let me click OK. Okay, so now we are done with the head office firewall configuration. So let me click commit, because actually I put all the rules and everything beforehand, because actually those things are not that much important when it comes to this configuration, because I'm totally focusing on the Palo Alto IPsec configuration. Palo Alto IPsec configuration using a pre-shared key. Okay, now it's fine. So then let me go to the branch office firewall. So then let me go to the network tab, and I think now let me clear this here. I think now this one moment. This IK crypto and the IPsec crypto, these two profiles. Those are IK crypto means all the algorithm that is going to be used for the phase 1, and IPsec crypto means all algorithm that is going to be used for the phase 2 or the IPsec phase. So let me create the IK gateway for the phase 1. Let me put the same name. You can put whatever the name you require. IKGW. I'm using the IK version 2, and the interface should be this one. This is the interface. So let me showcase that within the diagram as well. Okay, here let me get the pen tool. This is the interface, because actually this is connected to the internet. Or actually we are representing the internet using just router, Windows router, because actually in router in this Windows machine, actually I install routing and remote access service, so it acts as a router. So okay, that's fine. So let me minimize this, and okay, this is the interface, and this is the IP, and next my peer that is one 92168 100 dot 100.254. Let me check something because I don't know whether I put some different IP here. IP gateways, it is 172.16 Okay, something wrong here, so let me check. No, because I'm sorry, this is the interface. Actually this interface is actually the one moment actually this interface is uh, one moment, this one/1, not 1/2, I'm sorry, because 1/2 is the LAN site interface. So let me get the cursor. Okay, here let me select the IP, and then let me enter the IP 172.16 1.203. Okay, so that is my peer. So peer means my head office firewall interface. So let me showcase that by going into the interface. This one, I think you can see this is 172.16 1.203. Okay, that's fine. Let me put the pre-shared key. So I'm putting the same key here, because actually we have to remember that this key is not for the encryption or anything. Actually this key is in order to identify those peers, because when it comes to Diffie-Hellman key exchange, I'm not going to explain it here. Key exchange, actually we have to verify the peer, because otherwise some other third party can participate in this Diffie-Hellman key exchange, and we are going to exchange, or we are going to generate the key with that party. So that can be a security hazard, or that everything will be ruined. So in that case, in order to identify the party only, we are using the pre-shared key. So you can, because in my second demonstration, I'm going to showcase how to use certificates in order to identify the peer. Okay, that's fine. So then let me use here. I'm using IK crypto profile. That is the default one. No problem. Let me click OK. And now I'm going to create my IPsec tunnel. Let me go to IPsec tunnel. I'm putting the name IPsec. Okay, here let me select the tunnel. I think we have a tunnel, no problem. Let's use this tunnel. Actually, you can create a tunnel, but if you want me to show how to create a tunnel, let me create the tunnel. Let's put two, because the previous tunnel also not being used, so that's why I used it. But here, okay, let me, because here also I already created this security zone. If you want me to create the security zone, let me go to zones. There's nothing to do. You have to just enter the name here and click OK. Okay, so then I'm using IPsec, because actually I created this for something else. Okay, now it's fine. Let me click OK. I'm using the IPsec tunnel 2. Not IPsec, but a tunnel 2. I'm selecting the gateway, and I'm using the default IPsec crypto profile. And okay, sometimes you may have a question, what is this proxy ID? Actually, proxy ID means actually when you are configuring uh, IPsec tunnel with some other firewall or some other device that is having policy based VPN. Because when it comes to IPsec VPN, we have two types. We have route based VPN, we have policy based VPN. But when it comes to Palo Alto is using route-based VPN. But files like Checkpoint has only the policy-based VPN. In that case, actually, we have to use these proxy IDs. I'm not going to explain it here, but just keep that in mind. So that sometimes that will be helpful for you. Let me click OK. Okay, now it's fine. So now let me go to the virtual router and put the route. Before virtual router, static routes. Let me put the route here. IPsec, and my destination should be 192.168.100.0/24. That is my head office head office LAN. My tunnel is tunnel 2, because I use tunnel 2, and the next hop IP we don't want to put one. Click OK. Now we are done with our IPsec tunnel. Let me commit. Okay, so let me go to head office, and let me go to IPsec tunnel. Here you can see now our tunnel is down, because it's in red color, so that means our tunnel is down. Okay, so here let me go to IK gateways, and okay, so let's wait. Okay, it's 98% completed, and you have to remember that I think you can remember that previously. Let me log into the this internet router, because we need to get a packet capture here. What happened? So I entered the wrong password. Okay, here we have to take a packet capture. I think you can remember previous time we got a packet capture. So actually we got that packet capture. You saw that it was clear text. You saw the ICMP. I think it's better if I can showcase that again. What we can do is initial. Let's get the IPsec traffic. Then we go back to the clear text traffic and we'll compare. Okay. Okay, let me go to this machine. Now I'm going to initiate another ping request. So that request should be encrypted using IPsec. So, and the second thing is actually these, I'm sorry, these these red marks should be turned into green, these two, and within this firewall as well. Okay, so let me go to the Windows machine because I'm going to initiate a ping request. Okay, it takes some time because actually it takes some time to get IPsec negotiated properly. uh, we'll wait. Still request time out. uh, so let me go to the firewall and check whether we have any issue because sometimes there can be issues. Let me refresh. It's down. Let me go to monitor and let me go to system. Let me see whether I have any issue. It says there's a problem. What is the problem? Okay, it says, see, I think you can see there's a problem. Let me highlight it. It says IKSA negotiation is well likely due to the pre-shared key mismatch. It says pre-shared key mismatch. I think you can see here, right? We have this issue. So let me change. I don't know whether I mistyped the pre-shared key. Yeah, IK negotiation failed PSK. Okay, so let me clear this. I think it's better that you see these kind of errors, so then you know how to troubleshoot within your production environment. Because I can just post the video and I can fix the issue offline. But I think that is not a good idea because I don't want to tell you that I can just configure this at once and I can. I'm a genius. No, I'm not a genius. But the only thing is I need to teach you. I think this is pretty much important because otherwise you are going to see these errors within the production environment. But using my demonstration, you can see the issues. This is the issue. See, it says IK. I think you can't see using that, right? Let me remove. Let me try to increase the font size. I think using the magnifier I can because this is pretty much important. Zoom, not that zoom, but I need the no, not zoom, but magnify, right? Magnify, okay. See, this is there. I think you can see now. IKE V2 SA negotiation is failed likely due to pre-shared key mismatch. It says IKE authentication failure. I think you see now, right? So let me now, mark it here. See, this is the error. These are the errors. I think you can see, right? This is important. So let me try to make it correct. So let me close this. Let me erase this. Let me get the cursor. Okay, so then let me try to change the key because actually we cannot see the key here. IK gateways, IK gateways here we can't. There's no way to see, so we have to enter it again. I just put sys 123, but don't use this kind of a simple key when it comes to your production environment because this is since this is just a demonstration. I'm using a simple key here. So let me go to head office and let me change it. IK gateways. This is my gateway, and Cisco at 123. Cisco at 123. Okay, now we have changed the key within both the firewalls. Now I think it should work. This commit almost done. Okay, so let's wait for this commit operation. It's the 75% completed, 98% completed, 99. Okay, it's done. So let me go to Windows machine and see whether we have a chance. See, now it is working. Now we are so lucky. So the ping is working. So let me go to my firewall and show you. So let me go to monitor and show you. These logs are pretty much important. So because once familiar with these logs, it is you can, by seeing log, you can say that tunnel is up and running. So let me magnify the log magnifier, and this is the log. See, it says IPSec IK version 2. See, IK version 2 negotiation is started, and IPSec installed. Life size unlimited, lifetime is 1 hour, and using, and also here IK version 2 negotiation is succeeded as responder, and it is also saying that lifetime is 2800 something. Okay, so that means our IPsec phase 1 and phase 2 are up. So, and also there's an important thing that is SPI, security parameter index. So but I'm not going to tell you that, because when it comes to IPsec, we have something called SPI. We are using SPI in order to identify SAD, security association database entries. Don't think about it, I'm not going to explain it here, but I'm trying to do another demonstration for IPsec basics. Here this is totally focused on Palo Alto. Let me go back to this network tab, and here let me go to IPsec tunnel. See, it's green color, both the this is the phase 2 and this is the phase 1. And let me mark it. This is phase 2, not phase 1, even though it is in the first place. This is phase 1, this is phase 2, this is phase 1. So that's it. So now you see that our traffic is running perfectly. So then let me go back to this internet router here, and let me get the packet capture. Now you should not be able to see ICMP traffic here, because it is encrypted. You should be able to see ESP. See, ESP, encapsulated security payload. Encapsulated security payload. This is ISACAM means, that is phase 1. Internet that is a phase 1. So this is phase 2. This is the actual traffic. The traffic is encrypted. So let me stop it here and let me open this packet. This is encrypted packet. So you can't see any things. You can see these layer 3 and layer 2, and but you can't see anything in the payload. You can't see any payload here. A payload or anything. Other than the layer 3, you can't see, because it is it is encrypted here. See, let me mark it here. See, in this area you cannot see anything, within the packet, because it is encrypted. Okay, so then let me clean this, and let me try to showcase another thing here, important thing. Because actually I told you that when it comes to my previous let me try to get my whiteboard and the previous pages. I think here, how to get the previous page. No, I'm sorry. I think actually, I think you can remember that I told you when it comes to IPsec, we have two modes, like transport mode and tunnel mode. Actually, this is tunnel mode. So why I'm telling tunnel mode? Because actually, there's a meaning. There's a meaning between that term tunnel. Can you remember in previous demo, the previous actual traffic, or the clear text traffic before establishing this IPsec tunnel? When we ping from this head office client to the branch office client, we saw actual IPs. We saw source IPs 192.168.250, and the destination was 192. The source one was 192.168.150, and the destination was 192.168.250. So within the packet capture, we saw that. Actually, after this, I'll show it to you. But here you see the source is 172.16.1.203, and the destination is 172.16.2.203. So actually, the what happens is, let me get the whiteboard and show. Let me show you that. Here, let me get my pen. What happens is, the thing is, when it comes to this IP packet, the IP packet is like this. So here the packet is here, and this is unencrypted. Here we have this IP header. We have IP header. I'm sorry about my drawing. Here we have our, when it comes to, let's say this is a TCP packet. Let's say this is a TCP header, and also here's our, this, data section, or the actual data is here. But the thing is, when it comes to tunnel mode, what happens is this packet is going to be, encapsulated. Here we have two IP headers. Here we have one IP header, and we have another IP header. Actually, this is actual host IP, because when we are pinging from one host to another host, we are using our source host IP, and we actually in the IP header we have source IP and destination IP. So here we have that, actual the original IPs, but here actually this is the original IP details. But here the IP details of the IPsec device, that is our firewall, because in firewall actually this source IP should be our, the head office firewall interface IP, and the destination IP should be our, branch office firewall interfacing IP. That is the, the IP header we are adding, we are newly adding. But this is the old one. This is the old means actually this is the actual PC's IPs. That is, this is the source IP should be in this header, is the head office client IP, and the destination IP should be the branch office client IP. And here we have TCP header, and here we have data. And the thing is actually that this is going to be encrypted from here to here using ESP. And also here we have some ESP trailers as well. The ESP trailer also going to be added here, but I'm not going to explain in detail. So actually that's it. So because of that, this is actually a kind of a tunneling, because actually we are having another IP header we are going to add. We are going to tunnel this, because actually within the internet router we see only this, these endpoints, these two router IPs, head office interface IP and the branch office interface IP. But we are not seeing any head office client or the branch office client. So let me go back to this one. See, 172.16 1.203 172.16 2.20. Other than everything is going to be encrypted, except these things. So that's it. Okay, so then let me tell you another thing. Otherwise, okay, let me tell you another thing. No, let me terminate this. I just want to disable this IPsec tunnel. So let me disable this. Let me commit, because I just want to showcase the clear text traffic again. So let me go to IPsec tunnels, and let me disable this. Let me commit. Okay, let's wait for the commit operation to be completed. I think because I'm explaining certain basics here, but I'm not going to explain in deep manner, because actually this is totally focused on the Palo Alto IPsec configuration, because I'm planning for another demonstration which is totally focused on the IPsec basics. But here I'm totally focused on Palo Alto. Okay, it's done, and here also it's going to be done. Okay, so then there should be a difference. This is also done. Okay, so let me go to this internet router, and let me show you. Let me see whether we have ping up and running, but the ping is down for the moment. So let's wait. But we have problem, because since the IPsec tunnel is down, but the problem is actually we have a route. We have to remove that route as well, because otherwise traffic is putting into the tunnel, but actually since tunnel is not up and running, so the firewall cannot send the traffic. So let me commit it, and let me go to the second firewall, and let me go to default virtual router, and let go to static routes. Actually what I had to do is just to remove the route, but I just disable the tunnels as well. Okay, now we have to wait for this commit. So once this commit is done, actually the traffic is not going to the tunnel. it's going to be sent directly. So then I can show you the clear text traffic within the internet router. So this is almost done, this is almost done, so it's done. So let me go back to the router, but and this should get started, this ping request. See, now ping is fine. So let me go to the internet router and let me start the capture. Yeah, I'm continuing without saving. Now you should be able to see the clear text traffic. See, now the source is 192.168.100.50. The destination is 192.168.200.50. So this is not a tunnel. This is just a direct, normal traffic. But previously, because of IPsec, tunnel, you saw only the IPs of this head office firewall and the branch office firewall, and that's it. So then I had to tell you another thing. That is the last thing I'm going to explain. Let me go to this firewall again and enable the IPsec tunnel. Then let me go to head office and let me enable the tunnel. Before that, let me put the route again. Static routes. I think I don't want to explain because I explained you again. I mean, previously. So let me put the destination 192.168.200.0/24, and then my interface should be my tunnel interface, that is tunnel 2, and there's no next stop. Let me okay, and let me go to IPsec tunnels and let me enable the tunnel and click OK and commit. So let me go to second firewall, let me put the route, static routes, and IPsec 192.168.100.0/24, and my tunnel should be, in this case, tunnel 2 or 1, I think 2, and the IP should be none, and let me click OK, and let me go to IPsec tunnels and let me enable the tunnel. Enable, yes, commit. So then our traffic should be routed through the tunnel again, IPsec tunnel. See, now it is timed out because actually one side, the traffic is putting into the tunnel, but other side it is not sending the return traffic through it because actually the second firewall is still being committed here. So once done, we should be able to see the successful ping. Okay, it's almost done. Let's wait. Okay, now we should be able to see successful ping here because the traffic should be encrypted again using IPsec. Still we are having a issue, so let's see. So why take so long? So let me go back here. Let me check whether I did something wrong. Actually, we see that phase 1 is up and running, but phase 2 is down. So let me go back here and see whether we have. What's the problem? Let me initiate the ping again. But okay, no, it's not running. So let me go back here. Head office. Let me go to this virtual router. No, before that, let me go to IPsec tunnels and let me check. This is tunnel 2. Okay, let me go to this virtual IPsec tunnel and let me see the tunnel interface. It's also tunnel 2. So then let me go to virtual routers, and here in this virtual router I'm reaching 192.168.200.0/24. Okay, tunnel 2, that's fine. So let me go to branch office and virtual routers and default and static routes, 100.254 tunnel 2, that is also fine. So let me go to logs and see whether we have an issue. System logs are we have some problem. Version negotiation fail. So what can be the issue? We have problem here, but what should be the reason? So let me see whether I enable both the IK gateways. No, actually I disable IPSec tunnel, right? So it is okay. And let me go here. This is also enable, right? I think it's enable. Did I commit? Yeah, I did commit. So what can be the reason? So actually from the logs, I don't see any specific reason. IK version challenge question failed as initiated. So let me try to get the there's a one CLI command. So let me try to get that. Let me get the party and let me log into my firewall. 192.168.1.59. Admin. CLI is pretty much important when it comes to troubleshooting. So let me go to appearance and let me increase the font size. Okay, we have one command tail follow yes uh, ik sorry tail follow yes and sorry tail actually I can't remember this file that is tail sorry G, no, I'm sorry tail sorry no tail follow yes ik actually I forgot sorry mplog ikmgr I'm sorry ikmgr log. I'm really sorry because actually since this is a demonstration I forgot it all of a sudden, so that's it. Okay, let's see let's see whether we can see some clue here. It says I get child negotiation fail and key type no proposal chosen. It says no proposal chosen. I think you can see that. Let me highlight it here. See, it says no proposal chosen. See, so that is the issue. So that means proposal means when it comes to firewall, we can you remember that we select IKE crypto and IPSec crypto. So those are the proposals. What is the algorithm that we are using for encryption? What is the algorithm we are using for hashing? And what is the algorithm we are using for key exchange? And all those are the proposals. So let me stop it here. And this this is important. I think let me remove this and let me showcase that command. You just remember that command. The command is important. Tail follow yes mp log ike mgr log. So this is the log that we can see all the IPsec logs. So let me go back to the firewall. So let me see that when it comes to network, let me see whether I have problem with this uh, IPsec crypto, but we haven't changed anything, so that's a problem. It's ESP and these are the things, and group 1 hour. So let me go to phase 2, not phase 2, let me actually that is phase 2. Let me go to the firewall 2 IPsec crypto. This is a default and it's the same thing, I guess. Yeah, it's okay. Group 2 and here also group 2, right? It's here group 1. I don't know why, how it happened. So what happened? Sometimes because sometimes I may change something. Okay, let me click OK. So let me commit. I think that should be the issue. Okay, let's wait for the commit to be done, because actually that is two different, because actually here for group 2 group 1 and here group 2, so that's a problem. So now it should work. So let me close this. Actually at this moment I can't remember whether I changed it or not. but I have to check the previous recording, in order to identify whether I did something wrong. Okay, let's see. uh See, now it's working fine. So I think, but you see that how these troubleshooting is important when it comes to using CLI. Also, you can identify things, because otherwise, from the GUI sometimes you cannot find everything. So now it's fine. So what I'm going to showcase here now, let me see. Now it's ESP. Previously it was ICMP, right? It is clear text, and also the two IPs, source and destination IPs, not the actual IPs of the host. This is the IPsec tunnel mode actually. This is tunnel, because actually, okay, it's locked. It's no problem. I showed to you. Okay, now what I'm going to tell you is, actually, we have two phases, right? We have phase one and phase two. But the thing is, actually, you do not need phase one once the phase two is up, because actually, I told you phase two is the actual phase that we are sending the actual, traffic, actual encrypted data. So if the phase two is up, you don't need phase one. But the thing is, phase one, I think you can remember that we put this lifetime and all. So in that case, phase two is going to be expired. So once a phase two is expired, only you need phase one in order to negotiate algorithms, keys, and all for the phase two. So in that case, if the phase one two is up at this moment, if the phase one is down, no problem, your traffic should work. So let me showcase that here. So let me try to disable phase one. I think I can do that, I guess. How to disable phase one? Let me try to uh, let me try here. Uh, uh, okay. So let me go to this CLI. Let me try to down the phase one using this command. Clear VPN, IPsec, SA, sorry, not IPsec, IKSA, gateway, IK gateway. So let me try here. Sometimes it can be done using, no, actually, it is not. Uh, Phase one is not getting down. So otherwise, what we can do is, uh, so let me go here. Let me go to IK crypto, and let me get the crypto profile, and keep lifetime. No, actually, for the moment, actually, I can't remember how to, down this only the phase one. So actually, I wanted to tell you that, by actually phase one is not required when your phase two is up. But the problem is actually you need the phase one, because actually we need to renegotiate phase two. So in order to, exchange those details, actually we need phase one. So that's okay. So I think that now you see that how to configure this IPsec tunnel between two Palo Alto firewalls. So then, and also you saw these packet captures within this internet router, and also so that's it. So then I think you can now manage to build IPsec tunnels between two Palo Alto firewalls. Oh, one thing, because actually I think I miss something in the diagram. So let me go back. Let me get the diagram. Yes, here I missed, because actually when it comes to this, ESP packet, we have a ESP header. Because I'm not focusing on these all the structures and these basics. Actually, I did not focus on that. So let me get this color. Let me draw it here. So let me try to alter the same one. So let me have a section here. Okay, let's say this is the IP all new IP header, and this is the old IP header, and let me get the color, some different color, and let's say this is the ESP header. This is the ESP header. Actually, after the ESP header, from this place onwards, this is going to be encrypted, and also the including the ESP header. I mean, here I'm just giving the basic idea I'm not going to deeply explain. Here we have something called ESP authentication as well, ESP auth. So I'm planning to do actually basics video separately. So I think you got the idea. So thank you for time.